As you look at this piece of paper, you can see that I have drawn a line segment AB, I've drawn a line L, and I've drawn a circle P. But we're going to do something kind of interesting with these and fun today. Some that are not required that you learn, but just a fun thing to do. The first thing I want us to do is to construct an equilateral triangle. Now, to be an equilateral triangle means all three sides are congruent. So I'm going to take my compass and I'm going to measure from point A to point B. And I want that to be the length of each side of my equilateral triangle. So if I rotate and I cut an arc above my line segment from point A, and I also cut an arc above my line segment from point B, I will get two lines that intersect in a point, and this point is point C. Now we know that all radii of a circle are congruent, so therefore, since I have measured everything with a radius, I know that I can connect point A with my new point, let's call that point C, and I can connect point B with my new point, we'll call that we've named C, and I have constructed an equilateral triangle. Equilateral means all three sides are congruent. Now there's some very special facts about an equilateral triangle. It also is equiangular, which means all three angles will measure 60 degrees because the sum of the measures of the angles of a triangle is 180. And if I have three equal angles that equal 180, then each angle is 60. Now, I'm not trying to teach you that fact today. I just wanted to show you how to construct for yourself a triangle that was an equilateral triangle. I'd also like to show you how to construct an isosceles triangle. Now, I'm going to choose some point on my line, doesn't matter where. And I'm going to take that point and I'm going to cut arcs on each side of that point. I'm going to make my compass point a little smaller. So I'm going to cut arcs on each side of that point. And when I cut these arcs, I know that I have two segments that are congruent right here, because I know that this is the midpoint of the segment formed by these two. But I'm going to change the size of my measurement now. I'm going to open my compass more, much more, like we were constructing a perpendicular bisector. And I'm going to put my compass on this point and draw an arc up above. Let's open it a lot more. Let's get it really open a lot. Here, I'm going to try to open it real wide. I don't want it as wide as that. I want it a little smaller than that. So I'm going to cut an arc up here. And then I'm going to go to this point over here, and I'm going to cut the same arc. Now, you'll notice I have a new point. And if I were to call the original point, let's call this one X, and this one Y, and this one Z. If I were to draw a line from M to Z, that would be the midpoint line. But I'm not trying to do the perpendicular bisector or the midpoint right now, although we know that this is the midpoint. But rather, I want to draw a line segment XZ, and I want to draw line segment YZ by connecting these 2 points. Now I have constructed this to be an isosceles triangle. An isosceles triangle is a triangle in which 2 of the sides are congruent. These 2 sides are congruent. They are not the same measure. I want to show you. This is the measure for YZ. This is the measure for XZ. But that is not the measure for XY. Do you see that? That is not the measure for XY. Unlike over here, where I constructed an equilateral triangle, and we didn't write it down, but this is an equilateral triangle. Now I have constructed an isosceles triangle. 3 sides congruent, 2 sides congruent. Now, this third drawing, my circle, I'm going to show you what happens when we inscribe an angle within a semicircle. Now, we get a semicircle by drawing a diameter. And I get a diameter by drawing any line, doesn't matter where, that intersects the circle in 2 points and goes to the center. Now, P is the center. So if I draw across here, this diameter, I went a little far over there, but you know it stops at the circle. I can call this M and N, or let's call it N and O. We know that NO is a diameter. We know that P was the center of the circle, so that also means that NP and PO are radii, which are congruent. If you want to mark those 2 congruent, you can, because all radii of a circle are congruent. But now I can draw any other point on this circle, anywhere on this circle. Let's say I draw a point right here. If I'll call this point Q. If I draw a line segment from N to Q and from, I didn't quite get it there, did I? From N to Q and then from Q to O. I'm going to draw a line segment from Q to O. I have constructed a right angle. I'm going to put this little mark here. Now I know it's a right angle because you're going to learn later about angles. We've already talked about them, like when you had an equilateral triangle, all 3 angles were congruent, they all equaled 60 degrees. When you have an isosceles triangle, 2 angles were congruent. The angles opposite the congruent sides were congruent angles. But always, when you inscribe a triangle in a semicircle, and a semicircle meaning half of the circle, the arc that makes up half of the circle, this is going to give you the arc of this circle is 180 degrees, because we know the whole circle is 360 degrees, so a semicircle is 180 degrees, and the measure of this angle that's inscribed in this circle is always half of the arc. So what is half of 180? 90 degrees. So I know that the measure of angle Q is 90 degrees. So I have constructed a right triangle. And we can check it. I didn't check any of these when we were going along, but we can check it. We can check to see, yes, does this one equal 60 degrees like I expected it would? And bingo, it's right there on 60. And we can check these 2. Now, I'm not sure what their measure is. Not sure what the measure of this angle is. It appears to be about 57. Let's measure this angle over here. It also appears to be, it's a little hard to see it from up where I'm measuring. it also appears to be about, it goes 50, 55, it's 57 degrees. So we knew these were congruent. We constructed them to be congruent. We measured them to be 57 degrees. These we know are all 60 degrees, but we also measured it to be 60 degrees. Now, since I know that this is 57 and this is 57, I can determine what that angle up there is because all three angles equal 180 degrees. So if I add this up, I get 114. And if I subtract 114 from 180, I'll let you do that. You figure out what that other angle is. Now, we didn't check this one. Let's check it with our protractor. We measure angles with a protractor. And even before I came to check it, I knew it was going to be 90 degrees because I constructed it to be 90 degrees. But we can check it that way. Now, we could also measure to see what the other two angles measure. And I'll leave that up to you. You can construct a circle. Well, draw a circle and then construct an angle in a semicircle. Verify that you have 90 degrees, and then take your protractor and measure to see what the measures of your other two angles are. Just to verify, if you want to, they equal 180. This one appears to be about 58. So if this is 58, then the other angle must be about 32 because they're complementary. We'll check and see, just to kind of get an idea. It appears to be 32. But you can do this with, I said 58 degrees and 32 degrees, because we know that these angles are going to total 180 degrees. So there we have it. We've constructed an equilateral triangle, an isosceles triangle, and a right triangle. Have a blessed day.